From the moment raw materials arrive, efficiency is paramount. These stainless steel drums hold the advanced ceramic powder, crucial for production.
Careful synchronicity is essential when moving the ceramic powder drums into the designated bay. The advanced ceramic powder is precisely measured for quality analysis.
Once collected, the samples are immediately transferred to the quality control lab for analysis, ensuring strict adherence to protocol.
To ensure the quality of our advanced ceramic materials, particle size distribution is meticulously measured using this sieve shaker. The laser diffraction analysis confirms a monomodal distribution for the advanced ceramic powder, with a mean particle size of 500 nanometers.
The analyzer confirms the moisture content at an ideal 0.04%, critical for quality control.
Utilizing advanced spectrometry, we ensure the ceramic powder achieves 99 point.
As the final data points are logged, the system confirms the acceptance of the ceramic powder lot, ensuring quality assurance.
Quality control approval confirmed. The advanced ceramic powder is now cleared for the main processing line. Calibration complete. We ensure absolute accuracy before initiating the mixing sequence.
Weighing the ceramic powder requires absolute precision, down to the final gram.
A precise amount of binder fluid is injected into the weighed advanced ceramic powder batch. Once weighed and coated, each batch of advanced ceramic powder is segregated onto a dedicated transfer cart, ensuring strict quality control.
Loading the advanced ceramic powder into the high-speed ball mill mixer.
The technician initiates the start sequence by confirming the parameters. The rotation speed is set to 5,000 RPM. We are now initiating the high-speed milling process. The intense rhythmic grinding ensures a consistent and uniform blend. The turbulent environment within the mixer ensures the ceramic particles are uniformly dispersed, resulting in complete homogenization of the advanced material.
The mixing cycle is now complete.
Utilizing our high-speed ball mill mixer, the ceramic powder is discharged into a sterile, sealed container with absolute precision.
The second stage of quality control focuses on the advanced ceramic powder. We use a specialized spatula to ensure
Precision is everything. The advanced ceramic compound is now entering the forming stage. To form the green ceramic component, the highly polished inner surface of the steel mold cavity must be absolutely flawless before securing the mold halves. An automated nozzle precisely dispenses the advanced ceramic powder into the mold cavity. The system tracks the exact level.
Utilizing the dedicated conveyor, the mold approaches the CIP press, where it will undergo high-pressure compaction.
This chamber maintains pressures up to 2,000 atmospheres. The slightest deviation could prove catastrophic. Inside the chamber, the advanced ceramic powder is precisely loaded by the robotic arm before the pressing sequence begins. The final phase of the sealing sequence has begun. Prepare for maximum compression.
Now maintaining the isostatic hold. The pressure inside this chamber is currently exceeding 45,000 psi.
And with the pressure fully released, the system returns to a safe baseline of 0.
Once the cycle is complete, the CIP door retracts, allowing the robotic arm to carefully extract the newly formed green component from the mold. The initial green inspection is critical. We look for any microfractures or surface defects under high magnification. Here we see the green component being trimmed. The high-speed diamond bit removes the excess material, and the integrated vacuum prevents contamination.
The green ceramic component is carefully positioned on the heat-resistant sled, ready for the sintering process. The sleds carry the delicate green components into the massive kiln, beginning their transformation in the intense heat of the preheat zone. The sintering kiln begins its cycle,
rapidly approaching the initial dewaxing temperature of 400 degrees Celsius. The binder burnout phase ensures the complete removal of organic materials, leaving behind a pure ceramic component ready for sintering. This is the sintering zone, where the intense heat bonds the metal particles. At this temperature, the ceramic component begins to sinter, shrinking and densifying into a solid mass. Through atomic densification, the ceramic particles fuse together. This sintering process highlights the reduction of...
Now begins the crucial soak time. The kiln will hold at this sintering temperature for the next 6 hours, demanding patience and precision.
Beginning the cooling ramp. The temperature chart shows a controlled, slow descent from the peak temperature in the industrial sintering kiln.
After the sintering process, the components enter the final stage of cooling, ensuring stability and hardness.
Extreme heat is the crucible of creation. The sintering process transforms the raw component into a hardened, high-performance ceramic.
After sintering, the ceramic components undergo significant densification. We use digital calipers to verify the...
Under polarized light, we meticulously scan the surface for micro cracks and imperfections, ensuring the highest quality standards are met. The ceramic component is now transferred for secondary processing, ensuring precise alignment for the machining phase. The robotic arm ensures perfect alignment before the ceramic component is securely locked in the chuck, ready for high-precision machining.
The crystalline edge of the diamond tool provides the hardness required to precisely cut the fired ceramic component. CNC machining commences.
The continuous, high-frequency grinding allows for micro-scale material removal, showcasing the extreme precision of the synchronized movements of the 5-axis machining center allow for rapid presentation of the ceramic component, ensuring unparalleled precision and efficiency.
The coolant system ensures optimal performance by precisely managing heat and dust at the cutting interface.
Machining cycle complete. The fired ceramic component is finished.
Once the machining is complete, the robotic arm carefully extracts the flawless ceramic component.
Utilizing high-frequency sound waves, the ultrasonic bath ensures high-precision cleaning, removing all residual debris.
The fired ceramic component is gently dried by a precise laminar flow of heated, filtered air, ensuring a perfectly clean surface. Post-machining, the ceramic component undergoes micro-measurement via the optical comparator. The detailed profile scan.
The automated loading sequence is now active. The ceramic component will undergo high-resolution structural analysis.
Warning: the high-energy scan is commencing. Do not approach the chamber until the all-clear signal is given.
The scanner is currently in the warm-up phase. The unit is now active and generating the beam.
Scanning complete. The component exhibits perfect density and structural integrity. Status: pass. Analyzing structure. Depth scan active. Verifying absence of voids and cracks. Analysis complete. Component verified. Cycle complete.
The ceramic component is ready for extraction. Through the airlock and into the sterile assembly zone. Every precaution is taken to ensure zero contamination. The final layer of protection is secured. With the mask sealed and the specialized gloves fastened, the critical work can proceed. Precision is paramount. In this environment, every movement is calculated to ensure the integrity of the fired ceramic.
The fired ceramic component is now integrated with the diamond bearing element, completing the assembly. Precision at this level requires absolute focus. The margin for error is non-existent. The ceramic component has reached 40,000 RPM, showing minimal deflection within the pressurized chamber. A sudden blast of cryogenic vapor simulates extreme thermal shock, immediately freezing the ceramic surface.
All systems are nominal. Vibration, temperature, and stress profiles remain well within acceptable parameters.
Here we see the laser applying the geometric serialization marks directly onto the ceramic surface, ensuring lifelong traceability of the component. Precision is paramount. The ceramic component is now marked with its unique identifier, ensuring traceability throughout its life cycle. The ceramic component is secured within a custom-fit foam insert, emphasizing the high-value packaging. The fired ceramic component is gently placed into the high-density foam cavity, achieving a perfect, cushioned fit. Air is rapidly extracted from the protective pouch, ensuring a tight fit around the ceramic component. The final heat seal creates an airtight package.
The fired ceramic component is now sealed and placed within its serialized container, ready for final transport. Final labeling is critical. Our thermal printers apply detailed barcodes rapidly, ensuring every shipment is tracked precisely. Once the fired ceramic components are inspected, they are carefully stacked onto pallets for transport.
The automated wrapping machine secures the ceramic components tightly, preparing them for safe shipment.
Once quality checked, the pallets are moved efficiently to the shipping bay, ready for final distribution. The final scan complete. The shipment is cleared for departure. We utilize air cushion trailers to ensure your high-value cargo arrives in the same condition it left the dock. The shipment of fired ceramic component is now secure. The long haul begins, carrying the future of ceramic technology across the nation and beyond. Cycle start initiated. Pressure stabilization sequence engaged.
The green ceramic component formation is complete. It is extracted from the mold in a clean, rapid action using controlled pneumatic movement.
The green components are now entering the sintering phase, subjected to the intense, radiating heat of the kiln.
The component has reached peak thermal saturation. We are maintaining the current temperature for structural analysis.
Emerging from the cooling section, the ceramic component is now ready for precision machining and finishing. Observe the precision. The diamond tip carves the fired ceramic, bathed in coolant to ensure structural integrity.
Scan complete. Internal integrity confirmed. Pass.
The final adjustment. A steady hand ensures the alignment holds true, securing the integrity of the entire system.
The packaging process begins as the ceramic component is precisely guided into the protective foam, guaranteeing safety during transit.
The final shipping label is generated, ensuring rapid delivery to the customer.
Stack them tight and keep them square. A good pallet starts from the base, maximizing space and securing the load for its journey.
The cycle is complete. From concept to delivery, our commitment to efficiency never stops.
We maintain the strictest quality control. This consistency check is repeated for every sample to guarantee unparalleled purity.
Absolute cleanliness is paramount. We inspect every millimeter of the polished cavity before filling. Pressure stabilization achieved. The gauge holds steady at the maximum set point of 30,000 psi. The sintering process requires extreme temperatures to bind the metal components, ensuring unparalleled durability.
As the component moves along the final track, bursts of cool air stabilize the structure, visibly dissipating the intense heat from the firing process.
The 5-axis machining center utilizes an automated gripper arm to rapidly exchange tools, ensuring maximum uptime and clinical precision.
Post-machining verification complete. All parameters are within tolerance.
Our heavy-duty X-ray enclosure provides superior radiation shielding, cycling quickly for optimal efficiency.
In a world of microscopic tolerances, human focus remains our greatest asset.
Following extreme tolerance validation, the component is now being safely retracted from the testing apparatus.
Each unit is meticulously engraved with a unique serial number, guaranteeing authenticity and quality.
Our heat seal technology provides an impenetrable barrier, guaranteed not to leak.
With the final label applied, the boxes are routed for immediate palletizing, completing the cycle.
The outflow process ensures that every component reaches its destination on time. And so the work ends, as all things must. But from this silence, innovation will rise again.